Okay, can you say calculus?
Calculus.
What is calculus?
Oh, start again.
But Vivi, what is calculus?
Mm-hmm. It's a little bit bad.
What
It's
do you...
bad for your body. If you eat too much, you get tired and thirsty.
No, but honey, calculus.
That's what makes you tired and thirsty if you eat too much of it.
Okay, I don't think this is going well at all. Okay, this one's for the BC students. JP, I'll try to keep it under 5 minutes. Graphs of these two polar curves are shown in the figure. This is just a circle. This is the other one. Let R be the shaded region inside the graph of the circle and also inside the graph of the other one. Find the area of R. The way I look at it, you've got a quarter circle here. There's no need for any calculus. And then you have this region in the first quadrant. But for polar graphs, that means you're going to need to consider theta from 0 to pi over 2. And then add them up and that'll be the answer. Okay, for part B, for the curve r equals that, find the value of dx d theta at theta equals pi over 6. The key insight is that x equals r cosine theta. So at this point, you have an expression for x in terms of theta, and then you have a calculator. Okay, part C, the distance between the two curves changes for the interval 0 to pi over 2. Find the rate at which the distance between the two curves is changing with respect to theta when theta is pi over 3. The idea of this spatially is that you've got radii. So pick a given theta and just draw out to the curves, and the difference in the r values would just be the distance between the two curves. So that's the concept of it. So the upshot is you just subtract in order to find the distance. So an expression for the distance between the two curves is just given by the difference in the two. I hope that makes some sense. And then they say find the rate at which the distance between the two curves is changing. So you just take the derivative of this function that you've invented. Suppose I could have said that a bit fancier. Could have said d prime of pi over 3 equal negative 1.999. Same difference. Okay, part D. Particle is moving along the curve r so that d theta dt is 3 for all times t positive. Find the value of dr dt at theta equals pi over 6. So dr dt, that's not dr d theta, so you got to be thinking about the chain rule. And if you take dr dt, you will take dr d theta, but then you need to multiply by d theta dt, the chain piece. So this requires a derivative at pi over 6, but then again you have a calculator for that, and then you just multiply that derivative by 3. Well, here, dr dt is dr d theta times d theta dt, which is what I said before. And the idea again is at at theta equals pi over 6, d theta is something that we can get with the calculator, and then d theta dt is just always 3. So then we don't need to worry about that. That's it.